Very good morning to all of you. Today we are starting with a new topics in that current electricity chapter, and that is nothing but a very important topic known as Wheatatine Bridge. What is Wheatatine Bridge? Generally, Wheatatine Bridge is a bridge made by resistances of four resistances. Wheatatine Bridge is an arrangement made by four resistances in which three of them are known. Three of them are known and one is unknown. And it is that type of bridge or that type of arrangement where by knowing the three resistances we can find out the value of unknown resistance. Is it clear? What is that one? It is a arrangement of four resistances out of which three are known and one is unknown. By knowing the value of three, we can calculate the value of unknown resistances. And it is based upon the principle known as Wheatatine Bridge principle. What does it state? It states that if four resistances are arranged in such a way, that the current flowing through mid of them is zero. That is, the four resistances are arranged in such a way that they are in the balanced condition. In that moment, ratio of the resistances in any two adjacent arm is equal to the resistances in other two adjacent arm. Suppose we have four resistances P, Q, R, S. If these four resistances are there and in between them a galvanometer is there which having the resistance G, current is flowing through them. If the current is in balanced condition, this current is zero. That means the value of Ig is supposed to be zero. At that moment, the ratio of the resistances in adjacent arm, that is P by Q, must be equal to R by S. That is the what? That is your about the Wheatatine Bridge principle. Now, for that reason, what we have done, we have taken a resistance. Wheatatine Bridge circuit is like this, where the resistance is here, resistance is P, here resistance is Q, here it is R, and here it is S. How many resistances are there? P, Q, R, S. When no current flows to the galvanometer between them, then P by Q equal to R by S or P by R equal to Q by S, we can say. Now, the main thing is that we have to prove it. The question will ask, state the Wheatatine Bridge principle and prove it that P by Q equal to R by S. How can you prove it? For that reason, we have connected this A with the positive terminal of the cell having EMF E. And with that terminal C, we have connected with the negative terminal of the cell having with the key K1. Now if this cell gives the current I here, suppose this P is carrying current I1, then the rest of the current will go through the R and it will carry what current? It carries I minus I1. Is it clear? It will carry I minus I1. Now, if a current I suffix G flows through here, if the galvanometer draws the current, before balancing, suppose if it is taking the current Ig, then what will be the rest amount? Rest amount of current will be here. It will be I1 minus Ig is there. It will take I1 minus Ig. Now, if when it is connected, this is giving Ig and this is giving what? I minus I1. The total current will be how much? Ig plus I minus I1. Now we can see that from there, what is the current is coming here? This I1 minus Ig is coming. And from here this Ig plus I minus I1 is coming. So we can say the total current is I1 minus Ig plus I. And here it is how much? Here it is what? Ig plus I minus I1 is coming. From here we are giving that it is taking I1 minus Ig. This is taking how many current? How much current? I1 minus Ig. And this is current how much? It is current Ig plus I minus Ig. So this I1 will cancel out, Ig is cancel out, will get what? I. So first law is proved here. First law proved what? It states that whatever the current is coming inside must be equal to the current going outside. That means if I current is coming inside, the I current will go outside. The first law is proved. Now we are using Kirchhoff. We will use Kirchhoff's second law, that is Kirchhoff's voltage law here. So for that reason, we have to divide this A, B, C, D circuit in two regions. That is in two loops. And these loops should be closed. How we can make the close? If it starts from A, it will end to A. Suppose we are using KVL in loop A, B, D, A. That means it is a closed loop. A, B, D. What is the other loop? Other loop is B, C, D, B. We have taken two loops. One is A, B, D, A. Other one is B, C, D, B. Is it clear? Now we will use KVL in A, B, D, A. You see, what is the amount of current is going? It is going I1. What is the resistance here? P. So what is the potential here? I1 into P. Is it clear? Potential at A is I1 into P. Similarly, what is the potential at BD? It is ID into G. What is the potential at AD? It is I minus I1 into R. Now you see the direction. AB in this direction, BD in this direction. But DA, you are saying DA, but it is in the opposite direction. When it opposed, you should say that it is negative. When it is in the same direction of that connection, we can say this positive direction. So here I1P is positive, IDG is positive, and only I minus I1 is negative. Is it clear? I minus I1. So when you are using the KVL, you should say that what we can say that I1 plus I1 into P in the first, second one is ID into G minus of I minus I1 into R equal to 0. Why it is 0? Because in this connection you will see that there is no EMF of the cell is connected. Still there is some potential is there. So total potential is considered to be 0. So we can write this thing said what? I1 into P plus ID into G equal to how much? I minus I1 into R. This is taken to be equation number 1. Now you go through the second one. This is what your D, C, D, D. When you are using which one? Which principle? We are using D, C, D, D. In this case, what is there? We can write I1. What is the potential here? I1 minus ID into Q. What is the potential here? IG plus I minus I1 into F. What is the potential here? IG into G. But one thing you should remember. This is positive. But this is against this one. Because we have said BC. It is along the direction of BC. So it is positive. But we have said CD. But it is opposite. So it will be negative. Again we have said DB. But it is against opposite. So it will be negative. So we can write what? I minus. We can write I applying using KVL in loop BCDBA. We get I1 minus ID into Q minus I minus I1 into G plus S minus of ID into G equal to how much? 0. Clear enough? Now what we can do here? We can again shift. This one is what? I minus. This one is I1 minus ID into Q. Equal to how much? I minus I1 plus IG into S plus IG into G as equation number 2. What will happen in balanced condition? I told you earlier that in balanced condition, no current can flow through the galvanometer. If no current flow through the galvanometer, then what will happen? In balanced condition, IG is equal to 0. If IG is equal to 0, then we can write I1 into P plus 0. That means IG into 0 into G plus equal to how much? I minus I1 into R. So it results what? I1P equal to I minus I1 into R equal to equation number 3. And I1 minus 0 equal into Q equal to I minus I1 plus 0 into S plus Ig. The value of Ig is 0 into G. It implies what? I1 into Q is equal to I minus I1 into S. This is the equation number 4. Now, dividing equation 3 by equation 4, what we will get? Equation 3 by 4, what we will get? We will get I1P divided by I1Q equal to how much? I minus I1 into R divided by I minus I1 into S. These two will cancel out and we get what? P by Q is equal to R by S. This is about your Kirchhoff's voltage law. This is about your Wheatatine Bridge principle. Principle says that when no current flows to the galvanometer, that means in balanced condition, the ratio of the resistances in any two adjacent R is equal to the resistances in other two adjacent R. Is it clear? I think it will be clear. If you go through the video regularly, you can see that it will be clear to you. It's very important. It may be asked in your exam. In your final exam, it may be asked. And in school exam, it is sure that you will getting that questions also. That question you may get in the question. Okay. Now, it has a practical application of this Wheatatine Bridge. A very important practical application is there, known as meter bridge or slide wire bridge. Meter bridge or slide wire bridge. Next topic is meter bridge. What is meter bridge? Meter bridge is an instrument where you were applying the Kirchhoff's voltage law, where we are applying Kirchhoff's voltage law, and we can find out the value of unknown resistance. Kirchhoff's voltage law, and that means what? We are using the Wheatatine Bridge principle. We are generally using the Wheatatine Bridge principle in a meter bridge, and we can find out the value of unknown resistance. That is the use of Kirchhoff's voltage law and Wheatatine Bridge principle. And this meter bridge is generally what? It is a wire, it is an instrument which made up of 1 meter wire. So this is known as meter bridge because it consists of 1 meter wire. How it is made? In the practical classes you will see this one. But what is there? We have think that this wire is made up of 1 meter wire. And a copper plate is connected in this way. Here also a copper plate is there. Here also a copper plate is there. It is thick copper plate. So what will happen? We can say that here resistance is minimum. And here a known resistance is connected. Here the unknown resistance S is connected. And we want to find out the value of this unknown resistance. Now R and S is there, but we don't know what is the value of P and Q. Now what we will do, in the middle of this instrument, we will connect a wire through a galvanometer, and a jockey is there which can slide over this wire. So it is known as sliding. That's why it is known as sliding instrument, sliding wire experiment. Is it clear? Now suppose it is balanced. When you move the jockey on point X, suppose at point X it is balanced. So if it is balanced at X, then you can say this length we consider as L. We can measure this length by that scale also, but we can say this is L, and this is what your 100 minus L. Is it? This is your L. This is your 100 minus L. We know that every wire has a resistance. Suppose we have assumed that the rho is the resistance per unit length of the wire. This wire is a resistive wire. We have assumed that rho is the resistance per unit length of the wire. Then up to the point P, its resistance will be how much? So up to the point X and up to the length L, its resistance is considered to be rho into L. So it will be how much? P equal to rho into L. Similarly, Q equal to how much? Rho into 100 minus L, because the length is 100 minus L. So now we know that at point X it is balanced, that means galvanometer, so zero deflection. By using that Wheatatine Bridge principle, we can say that P by Q is equal to R by S. So we can say S equal to Q by P into R. So we can write what? In the value of Q, we can write rho into 100 minus L divided by rho into L. This rho will cancel out, will get what? 100 minus L by L into R. By knowing the value of L, we can calculate the value of L by the what? By using that what? Scale. By knowing the value of L, we can what? We can calculate the value of S because R is known. That is about your what meter bridge. In practical, what we will do? We will make all this connection in exactly practically the same instrument will be given to you. We will make all this connection. After making the connection, we will take out a resistance from here, high resistance. And if we move this galvanometer in this side, we will say that deflection is on this side. If we move the galvanometer this side, galvanometer will give the deflection in this side. If the galvanometer gives deflection in other opposite side, then we can say that our instrument is correct and our connection is also correct. And after that, what we will take? We will take one resistance here. Suppose we have taken 2 ohm resistance and we move the jockey on the wire. At some point, we will make what? We will see that the length is balanced. So we can suppose it is serial number 1 is there. We will give the practical. We will give serial number, a value of R, value of L, and 100 minus L, and it is what? S. That means this is P, and this is what your Q, and this is S is equal to Q by P into R. So what will be serial number? Serial number 1. Suppose we have taken value of resistance R, and we have taken suppose that length 48 is this balance, so it will be Q is what 52. By knowing that, by putting all this value in this formula, we can get the value of what? Unknown resistance. Similarly, by taking another resistance, after taking 2, we will take another resistance. Suppose 4 we have taken. Again, we will find out the different values and we can get the value. In this way, we will take 5 resistances and we will get that value. And the mean of this one will give the value of what? Approximate value of S. Is it there? So this is how we will do the practical. But what another thing we can do, if we after doing this one, this is the first case. What is the second case? What we will do? We will interchange this one. We will interchange. We will put this one here. In practical, I am talking about the experiment. We will interchange. We will put here S and we will put the R here. Then again, when we will use this one, then the formula will be what? L by 100 minus L into R, because we have already shifted this one. Okay. In that case, again we will do the same with the experiment. By putting that, by taking out 2, after that taking out 4, after that taking 6, we will get different values of L and we can calculate the value of S. In both the cases, we will see that average value of S are approximately equal. Is it clear? So this is about how we can do the meter bridge experiment, and this is the use of what? Meter bridge. Use of Wheatatine Bridge principle. Okay? And it is found that if the instrument is practically, if you have no error, if you are doing experiment in a correct way, if there is no error, then this instrument, this balancing length is exactly at 50 centimeter, exactly at the mid of the wire, and we can prove it mathematically. Is it clear? But in theory cases, you will see that sometimes 52, 53 is there. It will lie in between what 50, near the 50. But in practical, it will lie near the 50 because some errors came. Okay, resistance is there. Some current resistance occurs due to what? Due to the heat produced in the wire. All this will happen when there is a what? When we are going to do the practical in actual cases. But in theoretically, we can say that it is exactly balanced in the balancing length. When there is no error is there, it is at the mid of the wire, that is at 50 centimeter. Now we are going to prove it. Okay. We know if X is the unknown resistance, if instead of S, if it is X is there, X, then X equal to how much? 100 minus L divided by L into R in balanced condition. Now, if we take the log on both sides, then what will happen? Log X is equal to how much? Log of 100 minus L minus of log L plus log R. Isn't it? On differentiation, what we will get? ddx of log X is 1 by X. So, on differentiation, we will get dx by X. This will be what? D of 100 minus L by 100 minus L minus of dl by L plus 0. Why it is 0? Because it is known, it is fixed resistance, so it will be constant. So you can say it is 0. So we can write what dx by x is equal to D of 100 minus L give you what? DL, because 100 is a number. It will not be minus. That never be negative. So it will be DL. So it will be DL by 100 minus L minus of DL by L. And if the error is minimum, if exact value is X, what is that one error? Error is DX. If the error is minimum, that will be what? Dx is equal to 0. If dx is 0, then 0 is equal to dl by 100 minus L minus of dl by L. So we'll get what? dl by 100 minus L equal to how much? dl by L. So 100 minus L equal to L. It implies what? Twice L is equal to 100. Implies L equal to 50 centimeters. From there, what we can say? A meter bridge is exactly balanced when there is no error in the experiment. If the error is minimum, then meter bridge is balanced at the mid of the wire. They may ask you question. Prove that in case of no error, that meter bridge is what? Balanced at the mid of the wire. Please subscribe my channel and go through the video daily. You watch it, you can gather the knowledge. Okay. And if you have any doubt, you can call me, my number, and you can what? You can any doubt, if you go through that video, you can clear it. I know that. If you go to the video, watch it regularly, then you will see that it will be clear to you. Okay? Thank you.